Guys. Today we are talking about law of cosines. Yesterday we did law of sines. We had the new part was that we had that ambiguous case where we could have potentially two triangles or no triangles at all. And so the key to law of sines was asking yourself, does this triangle make sense? And so law of sines can be tricky. Bless you. But law of cosines turns out to be easier, a lot easier. There's nothing weird with law of cosines that we have to look out for. But the solving can be a little bit complicated. So really it's just calculator work and it's a formula. So again, I was going to derive how to get that formula, but I'm not going to. We are just going to write it down. I need another color pen though. Okay. So the formula for law of cosines, again, so we can use law of cosines. Usually we use law of cosines when we're given side angle side info on this particular one. So law of cosines also works on any type of triangle. It doesn't just have to be a right triangle. And what you'll notice again is we have a triangle that has capital letters for the vertices and the sides are the lowercase letters opposite their uppercase counterpart, okay? So we have little side A is opposite capital A, and little side C is across from its vertice capital C. Okay, so what we have is a lovely little formula. If I want to find little side C, I'm going to go ahead and circle my angle and this opposite side, and all it is a nice little pattern. So I want to figure out maybe this side, little c here. The formula is little c squared is equal to a squared plus b squared. A squared plus b squared. What does that remind you of? The Pythagorean theorem, absolutely. Okay, well that's kind of interesting. So it starts off like the Pythagorean theorem. Minus, but there's extra stuff here. So it's minus twice the product of those other sides, twice the product, so twice A times B, times the cosine of the included angle. So that is our big angle C. All right. So this is the pattern, okay? Little side squared is equal to other side squared plus other side squared minus twice the product of those sides times the cosine of the angle. And so if you set it up that way every time, it's just solving, okay? So we're going to get used to this pattern. So let's check out number 2 here. So what I'm going to do, I have my angle of 36 degrees, and I have this opposite side x that I'm trying to figure out. So will you please circle those? We want to highlight those. And my formula says I'm going to start with whatever my opposite side is squared. So we're going to start with x squared is equal to a squared plus b squared. Those are the other sides squared. So 12 squared plus 25 squared minus twice the product minus twice 12 times 25, so not minus twice the product of the sides times the cosine of our included angle there, that is 36 degrees. What mode should your calculator be in? Degree mode. Okay, I do not have a calculator. I definitely need one for this. Oh, thank you. I'm here already, so but thank you. All right, so this is all just calculator work. The nice thing is everything here on the right-hand side, it's all just numbers, right? Can we just plug it in our calculator? Yes, we can. Okay, so first I'm in degree mode. Make sure you're in degree mode. And then I can go ahead and put everything here on the right-hand side. 12 squared plus 25 squared minus 2 times 12 times 25 times the cosine of the included angle.
How do you switch it back to degree?
Mode. So you would go to the mode button.
And you go down.
And you'll see radian and degree in there, yeah. All right, so get it all in there, and I see that I have x squared equals 283.5898. And then how do you get x by itself? Square root both sides. So I'm going to do the square root of your answer. So again, don't round it off. You can highlight the decimal and suck it in if you want, or just do the second answer thing. So you get x equals, I'm going to say 16.8 will do. We'll round to the tenths maybe. So that must be 16.8 miles long, that third side. That's pretty easy, right? It's just a pattern. So on number 3, we need to draw our triangle. So I'm going to go ahead and draw my triangle on the side here, and it doesn't have to be to scale. But here I have my A, my B, and my C. And it says the measure of angle C is 88 degrees. So my C has 88 degrees. Segment AC is 22 feet long. So AC is 22 feet long. And BC is 11.5. So BC is 11.5 feet. And we want to find AB. So that's AB right here. That's what I'm trying to find, is that side X there. So I'm going to look for my side and my opposite angle. Those are the two pieces that are super duper important. All right, so I'm looking for my side squared is equal to, what should I write? Perfect.
Good job.
All right, yeah, so side squared plus side squared minus twice the product of those sides times the cosine of the included angle. And then again, everything is just calculator work from there on out, which is super nice. Okay, 11.5 squared, so the hardest thing here is making sure you type it in correctly. Minus 2 times 11.5 times 22 times the cosine of 88, and making sure that you're in degree mode. So I get x squared is equal to 598.5908 something or other, and then we need to do what? Square root both sides. So square root we get, 24.5 will do. And it looks like we're talking feet, so 24.5 feet. So again, it's a super long formula, but it's just a pattern, and once you learn that, really, it's pretty easy, pretty nice, easy pattern. And the nice thing is you can use law of cosines on any triangle if you've got the information necessary. So let's see. That was if we wanted to find a side length. So we can use the same thing if we want to figure out the angle. So here you'll notice this triangle, they've given us side, side, side info, side, side, side info. And we're trying to figure out the missing angle measure. So again, I'm just going to circle that angle and its opposite side, because that's sort of my little way that I figure out how to write my formula. Okay? And I have to start with my side squared. So this is going to be 10 squared is equal to 13 squared plus 11 squared minus twice 13 times 11 times cosine of x. Now, this one is different. This one requires a lot more effort here. Here, we have to go about trying to isolate the cosine of x. So we have to push everything over. All right? So I got to do some cleanup here. 10 squared is 100. Can I go ahead and put 13 squared plus 11 squared in?
Yeah.
All right, so I can evaluate that. 13 squared plus 11 squared, that's 290. And then all this stuff in front of cosine, I can also combine So that's a 2 times 13 times 12. Oh, sorry, 11. Just kidding. I don't know why I thought 12. All right. And so this becomes minus 286 times the cosine of x. All right, so I combined the numbers. I cleaned it up a little bit for what I could. Do not, ladies and gentlemen, do not do 290 minus 286. It is not 4. Don't do that, okay? These are not like terms. They do not combine. Instead, what do I have to do? Subtract 290. Yeah, we got to subtract 290 from both sides. So 100 minus 290 is 190, I hope. Okay. Negative 190. I suck at math. Equals negative 286 times the cosine of x. All right, now how do we isolate the cosine of x?
Divide by minus.
Yep, divide by negative 286. Divide by negative 286. Oh, I'm dying. All right, so I get the cosine of x equals, let's see, negative 190 divided by negative 286, and I get 0.66433, yada, yada, yada. How, right now, x is trapped inside its cosine house. Inverse cosine, very good. To free the x, we have to use cosine inverse of both sides. So cosine inverse and cosine undo one another. And so I need to do cosine inverse of my answer. So I'm going to do cosine inverse of my answer. And I get x equals 48.4 degrees. Okay? Easy or hard?
Really easy.
Pretty easy? Okay. Let's practice again. Okay. Let's look at number, I don't know. Do you want to do 5 or 6? 5. Okay, let's look. Oh, we have to draw 6. That's why you didn't want to do 5. I want to do 6. All right, we're going to do 6. Oh, funny. Yeah, you suck. Okay. All right, this is triangle RST. This is good because in Delta Math, you have to draw all of them. So again, capital letters. So RS is going to be a 9 here, 9 centimeters. ST is 14 centimeters, and RT is 6 centimeters. Oh, that's centimeters. There we go. And then we want to find the measure of angle R. So I'm going to put my X degrees right there. That's what I'm trying to figure out, measure of angle R. So I have my angle and my opposite side pair. That helps me set up my formula correctly. What do I begin with? 14 squared. The side squared is equal to what plus what?
6 squared plus 9 squared minus 6 times 9 times the cosine of x.
Perfect. Good. Side squared plus side squared minus twice the product of those sides times the cosine of the included angle. All right, we're going to do some cleanup. 14 squared is 289? Is that right? Oh, 196? Damn it. All right. And then I can put my, let's see, 36 plus 81 is 117. And then 2 times 6 times 9, I should probably be able to figure out that's 108. All right. All right, so I've done some cleanup with the numbers there. What do we do next? Whoops, what? Divide?
Minus 117.
Minus 117. Okay. Subtract 117. So 196 minus 117 is 79 equals negative 108 times the cosine of x And then we need 2?
Divided by negative 1/8.
Negative 108. So those go away. So I'm going to divide by negative 108. So I get negative 0.73148 is equal to cosine of x. And then how do we free the x? Inverse cosine. So cosine inverse of both sides. So cosine inverse and cosine cancel one another out. And so I get to do cosine inverse of my answer. And I get 137.0 degrees. Okay. I want to do one application here. Just because we don't talk about bearing very often, and I used to have a whole chapter just on bearing in trig many, many moons ago. So I want you to have seen it once or twice. So number 7, bearing measures the acute angle that a path or line of sight makes with a fixed north-south line. So 2 ships leave port at 8 a.m. Ship A sails with a bearing of north 68 degrees east. So what I have here is I'm going to draw a nice north-south line. So here's my nice north-south line. And right here is port, so we're going to call that port right there where that dot is. And one ship sails with a bearing of north 68 degrees to the east. So what that means is we know east is over here to the right. So they're making this angle here 68 degrees to the easterly direction, which means my ship is sailing this way, like that. Okay, 68 degrees east of north. Does that make sense to you? Yeah. Okay. And it's sailing at a speed of 17 miles per hour. Ship B sails with a bearing of south 35 degrees east. So again, now ship B is heading down southward, and it's going 35 degrees to the east. So it's moving this way 35 degrees. So it's sort of traveling this way. All right. So there's ship B at a speed of 12 miles per hour. If the ships maintain their paths, how far apart are they at 2 p.m.? Interesting. So we want to know how far apart they are. This is the question. How far apart are they? How many hours later? 6 hours later. We started at 8 a.m. and we want to know how far apart they are at 2 p.m. That's 6 hours later. Well, what distance did ship A travel in 6 hours? How'd you get that? 17 times 6 hours, 17 miles per hour, times 6 hours. The hours units cancel, and we get 102 miles there, okay? So ship A has a distance of 102 miles that it traveled. And let's see, my ship B, how far did ship B go? How'd you get 72? Yeah, it was traveling at 12 miles per hour times 6 hours. And hours cancel out, and 12 times 6 is 72. All right, so I have this great triangle. I have a side of 102. I have a side of 72 miles. I'm trying to find out this side. What's missing? What else do I need to figure out here? The angle. Yeah, what is this whole angle here? 75. Subtract from 180. Very good. All right. So 180, we can subtract the 68 degrees and subtract the 35 degrees, and so we get 77 degrees. So my triangle looks like this. We have a 77 degrees, 102, 72, and this is the distance we're trying to find there. All right, so we can set this up now. All right. how should I set this up? X squared, I'm going to use D. So D squared equals 72 squared plus 102 squared minus 2. Perfect. 77. All right. And I think you can do the rest, yeah? Yeah? Okay, so that's good. So I just want to talk a little bit about bearing, and then you can solve for D from there. All right, ladies and gentlemen, you have a delta math. Oh, that was only 20 minutes.